Hi guys, today we're going to continue to talk about how weather patterns and patterns in ocean circulation are going to affect climate. So your snow day assignment for this is to take some more notes on this lecture, and that goes along with that pink packet that you already have. And then there's one slide that you're going to need to print out, so go on Edline and go ahead and do that. You're also going to need to have a highlighter and something you can color code with as we go along. And then once we're finished with this lecture, I would like you to complete that white paper that I gave you a few classes ago. That's called Factors That Determine Climate. And when you're doing that, make sure that you're using some vocabulary, some of the things that we talk about during this lecture. Also, remember your biome projects are going to be due next class, whether that's Wednesday or a little later on. Either way, you need to be able to use some of this information to explain why your biome can be found in different areas of the globe. So just make sure that you're understanding kind of how this applies to that, and remember that's our greater big picture idea that we want to come up with. So let's start with just a quick reminder of what we're talking about before we break for your midterm. So remember, we have two different types of currents going on in the ocean. We have these surface currents, which are mostly caused by the prevailing winds, and where they hit the land masses, that's going to deflect them off in certain areas. And then we have these underlying currents that's called the ocean conveyor, which is more driven by density and temperature differences. So now we're going to talk about a few things that are related to that, and I want to draw your attention to some of these currents in this area right here. So you have this picture on your white paper, and we want to look at how these currents are crossing the ocean right here. And also in the same area, in our deeper current, we have this warm, less salty, shallow area coming across in the same spot that we have these warmer surface currents coming across. And remember, these warm surface currents are being caused by those trade winds in those areas, which are easterlies, so they're blowing from east to west, and as they're blowing, they're taking that warm water along the surface along with them. So this is going to result in another kind of convection current that we call upwelling. And upwelling is basically when the trade winds push that warm water all the way west, and then it meets the landmass on the other side, starts to sink, cools down, and starts pushing everything back up the other way around, so you get this convection cell going on. And what this is going to cause is you're going to take that cool, nutrient-rich water that's down at the bottom of the ocean, and that's going to be brought up because of this convection cell. So you have that warm water being pushed away from these eastern coasts, or really it's the western coast of South America, but it's east in terms of being on the Pacific Ocean. And that warm water is going to be pushed away, and that cold, nutrient-rich water is going to come up to the surface, which is called upwelling. And that cold water, when it comes up, it's going to bring with it a lot of nutrients like nitrates and phosphates. It's going to allow a lot of fish to live in these areas. So any of these red areas around the map here, and I'd like you to color code these on your map as well, this is where upwelling is going to take place. And you're going to have a lot of fisheries that try to catch fish in these areas because these nutrients come up. That's going to raise the primary productivity, which is going to raise your overall biological productivity in that area. Now, as we're going to see, this upwelling pattern is going to be affected by different changes in climate, which is one of the reasons why we're concerned about what could happen to these surface currents as a result of climate change. We talked about last time the potential impact of Greenland. If its land ice melted, what that could do to the ocean conveyor potentially. And the other thing that could go along with this is if the oceans warm significantly and you lose some of this convection that's going on beneath the water, then you have less upwelling, and because you have less upwelling, you'd wind up with less plankton to produce the food for everything else to live on. And then as a result of that, remember, warmer water is also going to hold more CO2, so you'd have more acidification in the oceans. You just have a slower circulation pattern in general, and that puts a lot of our climate and weather patterns up in the air to a point where we don't really know what the potential impact of that could be. Now there's one more force that's influencing the way that water is moving within the oceans that we haven't talked about yet, and that would be the tides. So tides are really caused by a gravitational pull of either the moon or the sun. Most of the time we're talking about the gravitational pull of the moon that's causing the majority of these tides. And whenever the moon is pulling the water, it will form almost a higher area on Earth, where the water is actually higher here because it's so much more attracted to the moon. And it's also going to form a shape like that on the other side. Because of the physics involved here, it's going to bow out like this on both sides. So you can think of this as the sea level, and the sea level is actually higher over in these areas than it is in these low tide areas on this picture. Now you might hear these words used, diurnal tides versus semi-diurnal tides. Diurnal tides occur once every 24 hours, so you'd have one high tide and one low tide. A semi-diurnal tide is going to occur more than once. So it's most common on Earth for you to have a semi-diurnal tide where you're seeing a high tide followed by a low tide, and have that cycle repeat every 12 hours or so, so that you'd have a high tide for 6 hours, and then 6 hours later you'd wind up with a low tide, and it would cycle back and forth. But again, that's being caused by the rotation of the moon around the Earth and how it's pulling the water with it as it travels around. Now we have a couple of special types of tides that you should be aware of, because they can impact what the climate is going to be like in an area in a certain period of time, or really at that point we're talking about weather patterns. And in these cases, with a spring tide and a neap tide, we're not just talking about the moon, but also the pull of the sun is going to cause the tide. So in a spring tide, you can see that they are lined up straight across in a line, such as the sun on one side, the moon on the other, and that is going to cause both sides to be pulled outwards even more so than they normally would. So your spring tides are your strongest tides because both the moon and the sun are pulling in opposite directions on that body of water. And then our neap tide is our weakest tide. So in this case, you can see that the sun and the moon are at 90-degree angles from each other, with Earth kind of at that middle point. And that's going to cause less of a bulge because the gravitational forces are sort of fighting against each other. So when we look at these in terms of when they would happen, you have the Earth here, which is of course rotating around the sun, and then you have the moon, which is revolving around the Earth. And you tend to see spring tides right in between the new moon and the first quarter moon, and usually very close to that new moon. Your neap tides are right around the first quarter moon, and then you'll see a spring tide again right around full moon, and another neap tide around the third quarter. So new moon and full moon are associated with that spring tide because the moon and the sun are going to be directly in line with each other at that point. And then the first and third quarter moons are associated with those neap tides. That's when we're going to get those 90-degree angles. So here's just one more picture that kind of shows you what's going on in each of those situations. And I just like this one because you can really see how the 90-degree angle might change in direction, but it's still, the major overall effect is still staying the same. So each of these tides, again, is going to happen twice per month, and they're going to be your lowest and highest tides of the month. Alright, so now that we've wrapped up all of the different ways that the ocean patterns are controlled, now we want to go back and think again about how those ocean patterns are going to interact with atmospheric patterns around the world. And I'd like you to take a minute here and grab some colored pencils or highlighters or whatever you have around. And I want you to color code this picture just like it is in the picture on your screen, because on your printout you can't really tell what color is what. So we're going to see that by all these ocean currents moving around and taking their weather patterns with them, we wind up with drier areas or wetter areas, cooler areas, and warmer areas, all because of that interaction between the ocean and the atmospheric wind patterns. And we're going to talk more about this, and we'll come back to why we'll be doing this in certain areas throughout the next week or so. But start to be looking for these patterns and trying to figure out why you get certain weather types in certain areas, because that's really going to lead you toward understanding why you would find particular biomes at certain places. So we started off this sort of part of the unit talking about specific heat of both water and land. And there's a reason for that. That's going to become really important in explaining why we have certain climates where we do. So remember that water has a much higher specific heat, and that means that it can absorb more energy. And the reason it's really doing that is because it has so many intermolecular bonds, those hydrogen bonds in between the water molecules. So in order to make water change phases, you're going to have to break and rearrange those bonds, which is not an easy thing to do. So that's going to cause water to heat slower and to cool faster. That's going to mean that in the winter, the water is going to be warmer than the land because it's not going to cool down as fast. In the summer, the water is going to be cooler than the land because it's not going to heat up as fast. Now, that water is also going to have an effect because it's going to add humidity to the air, because you constantly do have some water molecules escaping and going up into the air, and the warmer it is, the more humidity you're likely to have as a result of that. Don't forget that there are pressure patterns involved here as well. So if we go back and we think about the Hadley cells that are coming up by the equator, remember that they're creating this really low pressure zone right here at the equator, where a lot of rain is going to come right back down as this water cools off and drops its moisture. And remember, part of the reason why we have so much moisture going up here is most of the world around this area is ocean, first of all, and it's getting very direct sunlight, so that's causing a lot of evaporation to go up right there, causing that low pressure zone because it's pushing upwards. And then the prevailing winds, the trade winds that are going to come in here, are going to blow this over the land masses in each area. And land masses are going to be even warmer than the ocean water since they have a lower specific heat. They're going to they're going to absorb that heat more easily, and that's also going to push this warm air up even further in these areas and make it rise even more. And then when that warm air rises and it gets to a point where it's dropped all of its water, it's going to keep rising until it starts to cool off. It's going to sink back down in these subtropical areas, and that's why you're going to get these areas of high pressure, and you're going to be really likely to find deserts in these areas because that air is sinking downwards and pressing all that water close to the ground. And then remember, you're going to have your other cells that are coming in here. So your feral cells rotating in the middle, and then you have your polar cells up by the south and north pole. And you're going to have kind of the same pattern repeat all over again, where you have these wet areas of low pressure, and then your high pressure areas where the cold air is sinking back down. You're going to have very little precipitation. So it's important to keep in mind these overall convection cells that are happening at a much higher level in your atmosphere, but then we're also going to have localized convection cells that are going to be really important here too. And again, they're going to come back to the difference in specific heat between water and land. So if you think about in the summertime, or just on any nice day, you're going to have a condition where the land is going to heat up a lot faster than the water because of its lower specific heat. So that land is warming up, it's going to warm the air right above the land, and that's going to push that warm air upwards since it's less dense. As that warm air is rising, the ocean water is a lot cooler, so the air right above the ocean is going to be cooler, and it's going to follow that warm air in. And this is going to result in a cool sea breeze during the day. And then this also goes along with this pressure pattern. So remember, anything that's rising, it's going to be low pressure because it's pushing upwards. So that warm air, as it pushes up, it's low pressure, it cools, it falls back down into this high pressure area right over the ocean, and then that high pressure pushes in. This also explains why we get that cool sea breeze, because remember, winds are going to blow from high to low. So we're setting up these pressure zones here. At night, this whole pattern is going to switch around, and you're going to get a land breeze going out onto the ocean. And again, that's because of that high specific heat of the water. The water's not going to change temperature very easily, so the water's going to stay a lot warmer than the land is. The land cools off quickly, and that warm water is going to warm the air over the ocean. It's going to push it upwards, create this zone of low pressure. And then that cool air over the land is going to rush in to take its place and create that high pressure zone, pushing everything down and away. And this is going to cause a lot of the weather patterns that we see as well. Now, another pattern that we're going to see is the Rainshadow Effect. In general, any kind of long journey over a continent is going to dry the air eventually because you're just going to lose a lot of that humidity as it travels, and there's not a lot of water on the continental land itself to evaporate and replace it. But when you have a mountain or some sort of high elevation in the way, that's going to cause a very significant pattern to develop. So when you have this kind of situation, you're going to have warm, moist air coming off of the ocean as it blows inland, and it's going to be carrying a lot of humidity with it. And during the daytime, as we talked about, you're going to have this moist, warm sea breeze, and this water is going to travel up the ocean coast and up the mountainside. And on this side, which is called the windward side, it's the side from which the wind is blowing, you're going to see a lot of heavy rainfall develop as it travels up the mountain. And that's because that warm, moist air is getting up to a point in the atmosphere where it's cooler. And when it's cooler, remember, it can't hold as much water. It's going to drop that water down, and you're going to have a lot of rain. But then by the time it makes it up and over the mountain, it's so high up, pushed up in that troposphere, that it's going to have let go, basically, all of its water. So by the time it's coming down, it's going to be sinking, it's going to be dry, it's also cooled off, so it's more dense. So this is going to create a really high pressure area, and you're going to wind up with usually deserts in this area, which is called the rain shadow of the mountain. And this is also called the leeward side of the slope, where you're going to have that high pressure, that sinking air that will create those desert areas. Now, when we start to put this together with that land and sea breeze effect that we were just talking about, you start to see explanations for some things like monsoons. So monsoons are seasonal patterns that we see in winds and in rain patterns, particularly in this area of the world that's in yellow right here, which again you might want to go over on your slide with a particular color. And in this case with the monsoon, again, it's caused by the solar radiation coming in and warming up the land and the oceans unevenly and creating these zones of high and low pressure as a result of that. And this happens seasonally because in the summer, your land is going to be a lot warmer. And when the land is a lot warmer, it's going to have that hot air that's starting to rise and push upwards, and there's also all this water coming off of the oceans right in these areas. So you have really warm areas with high humidity, and as that air pushes upwards, it's going to drop all of that humidity basically as rain, and you're going to get these monsoon rains that are absolute downpours. And it's going to leave all that rain behind as it pushes back over the ocean, cools off, and sinks back down. So you're going to have a high pressure area over the ocean, a low pressure area over land, and that's your summer monsoon pattern. So that would be the wet season in these areas. And then they also have a dry season in the winter. In the winter, it's going to be the opposite kind of situation because the water is going to be warmer at that point than the land. And that's because the water, again, is holding on to more heat. So that warmer ocean is going to warm the water. All the precipitation is going to happen over the ocean as that low pressure zone pushes upwards, and then by the time it cools, it's going to have gotten rid of all its moisture and be sinking down in a high pressure area on land, causing a dry season in these climates. So again, you can see that pattern happening here, where you have this spring or summer pattern of really heavy rains, wet season, and then this winter pattern of much drier air. Now, when I say it's cooler and drier, I am talking relatively. If you look at the region that this is in, it's all right around the equator, so they're receiving pretty direct sunlight pretty much all year long. But it may be warm, but it's not as warm during the winter as it is during the summer. Also in India, part of the reason why it's so dry during the winter is that the air is coming off of these Himalayan mountains over here, and the Himalayas are forming a barrier, and this rain shadow effect is taking place so that all the moisture is staying on that side of the mountains, so that you're not really getting any of the impact of the air mass coming from this part of Asia. You're really only getting the impact of the water that's nearby. and all that cold air and moisture coming off of Asia gets blocked so that you have these hot, dry winters. Still, again, not quite as hot as your spring or summer. So let's just take a second here and think back about all the things that we've talked about so far. Remember that our wind patterns in the atmosphere are affecting our ocean currents, especially the surface currents. We have temperature and density patterns that are affecting all sorts of convection cells moving both in the ocean and in the atmosphere. And a lot of those are involved with weather patterns. A lot of those are also involved with things like upwelling, which is how the ocean is going to circulate some of its parts around. So we have this very tight interaction between ocean movement and atmospheric movement. And that's going to cause a lot of these interactions with the atmosphere where you wind up with certain areas that are being warmer or cooler than others and wetter or drier than others. And that's because of both the wind patterns and also the ocean circulation patterns. So you have these warmer areas that are being blocked by the mountain ranges here, so the rain's not getting in when the wind is moving one way, but you also have the monsoon pattern that's going on there. You have Europe, which is being warmed by the Gulf Stream, so it's warmer and wetter than it would be on its own because all that water, all those weather patterns are traveling up in that direction. You have this area of the United States, which is both cooler and wetter than it would be at that latitude because of the Gulf Stream dipping, the jet stream dipping down here and pushing the weather patterns down with it. So there's a lot of really intricate interactions to understand here. And now we need to talk briefly about severe weather. And severe weather, remember, is going to happen at those fronts. And remember, the fronts are going to form whenever two air masses are moving and colliding with each other. They're usually going to form along these jet streams that we talked about. And remember, the jet streams are moving in between these convection cells that are at a much higher level in your troposphere. So you're usually going to have fronts moving along this, and where that front moves is going to change depending on the seasons and depending on what's happening with that jet stream. But there's several types of severe weather that could happen if you do have the perfect conditions. So just want to remind you, we have two overall kinds of fronts that you need to be concerned about, warm fronts and cold fronts. And the warm fronts, you have a warm air mass coming in and replacing a colder one. And when that happens, you have warm air rising and you have rain, but it's going to be a more gentle rain. It's when the cold fronts come in and the cold air takes over and pushes down and forces the warm air way up. That's going to create thunderstorms. And those thunderstorms are going to expand very far upwards into the troposphere and sometimes even bordering on that stratosphere. So you're going to get these massive cumulonimbus clouds, which are also called thunderheads. And that's because that cool, dry air is coming in and forcing that warm, humid air all the way up. And that warm, humid air is going to continue to rise as long as it still weighs less, is less dense, and stays warmer than the air that's surrounding it. So you're going to get these storms developing. And then once the air starts to cool, it's going to drop all that rain back down. You're going to have, in some cases, very severe thunderstorms depending on how fast this happens, how close your temperature is to your dew point, and a lot of other factors. And one of the things that can develop during these thunderstorms are tornadoes, which are basically just cyclones of air that are swirling around, and they can have wind speeds up to 300 miles per hour, but they're just in one particular area. And the central area of these tornadoes is a low pressure area. You have this spinning cyclone effect, which we talked about a little bit earlier on. Remember that low pressure means that everything's going to be pushing upwards through the center of this cyclone, and this warm updraft is going to start spinning it in a loop. And part of the reason it does this is something called wind shear. In these areas of these thunderstorms, you have wind speeds and directions that are changing with height as you go up in altitude. So you have these winds that are shearing in at different directions and all kind of hitting each other and starting to swirl together. And if you have the perfect conditions, you will get either a tornado over land or a water spout over the water. And these do generally tend to happen a little bit more over land because the heating of the surface of the land is going to develop that thunderstorm, and then as those thunderstorm winds start to hit each other, you're going to develop that vortex. Now, another phenomenon that's going to be similar to this is a hurricane. And hurricanes are the most severe weather phenomenons on Earth. And just for one example, Katrina back in 2005, that caused $81 billion in damages and over 1,800 deaths. So see, these are some of the most destructive weather patterns that we see. And basically they're a giant rotating tropical storm, so there's several thunderstorms that have combined together and are swirling around in this pattern. And they're pretty much always going to form over areas where you have a high amount of water. It's warm water in the tropics. It's usually right where the trade winds converge, so they're pushing at each other in different directions, which is part of what's causing this swirling pattern. So a lot of times these hurricanes will form somewhat near the subtropical high pressure zones. That high pressure is going to cause really hot days and low humidity since it is pressing it down, but that is going to also allow a lot of evaporation in the surrounding areas where the pressure is lower. And as these thunderstorms build, if the conditions are just right and the water is very warm, they're going to start swirling together, and the Coriolis effect is going to come into play there also, because these are going to go clockwise in your northern hemisphere and counterclockwise in your southern hemisphere, just like our currents, just like our wind patterns. Now, the only difference really between a cyclone, a hurricane, and a typhoon is where they're located. So on this map here, you can see kind of the patterns of different hurricanes that we would expect to see. Most of the ones that are going to affect us over here are going to come kind of off the coast of Africa here and up here. So these are hurricanes. Anything in the Atlantic overall is called a hurricane. In the Pacific, they tend to be called typhoons, especially when they're coming over in this pattern and hitting this side of Asia. And in the Indian Ocean, when they come up this way, we would tend to call them cyclones. But it's really all just the same pattern over and over. And this is the way that these hurricanes are forming. So that warm, moist air is coming from over the ocean, and then as it rises, that water vapor is being brought up with it, and it's cooling, it's condensing into liquid droplets just like any other storm would form. This continues to make it rise, and as more and more thunderstorms start to join it, you start to get these distinct areas developing. The eye is an area of very low pressure. Everything is rising up and out of this eye, so you're not going to have really any rain coming out because it's going to get captured by these swirling winds around it. The winds are going to get weaker as you go up higher because they're going to be pushed further outwards at those altitudes, and they're going to start to spiral around. The precipitation is going to be highest right around that area of the eye. The winds are also going to be moving the fastest there, since that's where they're spinning the most. So they're going to build up over these warm waters, and then they're going to be able to move out, kind of following the patterns of those prevailing winds and also the pattern of the jet stream. Now, as these become more intense, you're also going to see that right around this eye, you're going to have a great amount of storm surge, and that's because it's literally kind of pulling the ocean up as you have this low pressure zone pushing upwards, and it's literally raising the sea level underneath the eye, and that causes all that storm surge, which then hits the coastlines and can cause a lot of damage. And this can even happen in cold water storms such as the blizzard that you're home for today, because you do get such storm surge. We saw that if you go online, you see that the Ocean City fishing pier was taken out by it just recently, and that's because that low pressure zone literally pulls the water up with it. So there's a lot of different factors that are going to influence the strength of these hurricanes and also the frequency of the hurricanes. And the number one thing is the surface temperature of the ocean. The warmer the water is, the more evaporation is going to happen naturally, and that's going to create bigger, stronger storms. Also, if it's raining in Africa, that's going to impact how likely we are to get a hurricane. the more rain there is in Africa, the more hurricanes you're going to get, because again, you're adding that precipitation, you're adding that humidity. Also, the dust is going to help prevent hurricanes overall. And then there's a third factor that's going to also affect the frequency of hurricanes, and those are ENSO cycles, which basically stands for El Nino Southern Oscillation, which you've heard a lot about lately too, since we are in an El Nino year. So we're going to talk about this over the next week or so. When we come back to school, we're going to be talking about El Nino cycles and how that's going to impact weather as well. So you do have the basis at this point for all the different convection cells that are going to come in and impact your weather. So what I want you to do now is go ahead and go to that Factors Determining Climate classwork that you received the other day, which has your pictures of your mountain ranges, your pictures of your surface currents, and start to try to put all this information together and understand why we're seeing certain biomes in certain places. So you're going to go ahead and answer the questions on there. I would also encourage you, if you can, to be working with somebody else that you're in contact with through text, over the phone, however you want to do it. That will help you talk it out and think it out as well. Just make sure, again, everything's in your own words. And then also, as you're finishing up your biome projects, I want you to be taking all of this stuff into account as well and trying to figure out how all these different convection patterns influence where you find your biome. Why do we have deserts in certain areas? Why do we have forests in certain areas? Why are grasslands more inland, forests more towards the coast? Start thinking about all those things and how they might be caused by the way that water and air is moving in these different areas. All right, and then I will see you when we get back, hopefully on Wednesday. If not, keep in touch so you know what's coming next. All right, let me know if you have any questions, and we'll see you later.